Hi guys, my name is Jordan Ignacio, and I'm the founder of Alpha Mutt. At Alpha Mutt, we create innovative pet products that help pet owners easily train and entertain their pets. So this here is an image that I'm all too familiar with. One day, I came home after a long day of work. I opened my front door and I found a trail of foam leading up to my bedroom. And I followed that foam, and that led me to my bed, which had a hole directly in the center of it. So while I was away at work, my dog decided that she was bored and she wanted to dig in my bed. So that was one bed. And then a few months later, after buying a new bed, she did the same thing. And so I decided I needed a solution to this problem. I didn't want to keep her locked up in a kennel all day, and I didn't want her to keep her locked up in a room all day. I wanted her to be loose and enjoy herself, but I also didn't want to risk my furniture being damaged because, as I found, mattresses aren't cheap. So I went online and I tried to find some products. Unfortunately, a lot of the products that I found were either inhumane, obstructive, or ineffective. The two products that you see here, this one is Couch Defender, and this one is Paws Away. Those are the two that are probably closest in terms of competitive landscape to AlphaMutt's product. Unfortunately, Couch Defender is very obstructive, as you can see. You have to remove that device every time you want to sit on the couch and then remember to put it back on. And then Paws Away is effective and it's not obstructive, but it's not humane. It utilizes shock to deter the pet from jumping on your couch. So at Alpha Mutt, we created our first product, which is a device that trains pets to stay off the furniture in a humane, effective, and non-obstructive manner. So how it works is it's comprised of two components. One component has 4 load cells in it, and those 4 load cells get placed under the couch or under a bed. It converts that piece of furniture into a weight scale, much like the bathroom scales in your bathroom. And what it can do is it can detect when your pet is on it, and it can detect when you are on it. If it detects that your pet is on it based off its weight, it sends a signal to a device that's on the collar. And that device then vibrates and emits a loud noise. In regards to the market, currently the pet industry is a recession-proof market. It's never experienced any recession. It's constantly increasing, with an average between 3 to 9%. And this year alone, it's estimated to be over $69 billion. In regards to the number of U.S. households that own a pet, dogs and cats consist of over 100 million. So there's quite a bit of dogs and cats out there that could utilize this device. A little bit about myself and my 2 dogs. The one on the left is Lily. That's the one that likes to dig through my mattress. And on the one on the right is Daisy. She doesn't dig so much, but she sheds a lot. So it'd be nice to keep her off my furniture as well. A little bit about myself. I'm currently a graduate student here at Lehigh, the Technical Entrepreneurship Program. I'll be done next Wednesday. Prior to that, I worked at a design and manufacturing company in Allentown called Ecotech Marine. Prior to that, I graduated from Lehigh with my bachelor's in mechanical engineering. That's a little bit about me and what I've done and my dogs. I'm here today to see if anyone is interested in working with me on this project. My background again is mechanical engineering, so I'm pretty good at designing products. In regards to PCBs and programming, that's not my strong suit, but I do know a little bit about hardware, and I have designed my own printed circuit boards. But when it comes to programming them, it's a little bit more complex. So I'm here to see if anyone would like to join me and work on this project with me, and I'm also looking for advisors that have experience in this field. So now I'll show you guys a quick demo of how it works. I have 2 versions. This one that's on the couch currently is my second prototype, and this one here is my third. The main difference between these 2 versions is this one is wireless and this one is not. So I'm going to show you the wireless version. And so right now I'm turning on the load cells, and they're all sending signals to this device here, which goes on the collar. Of course, the final product wouldn't be this big; it'd be more like this, the size of this guy here. And what would happen is I would turn this on. I would place the dog on it with this collar. I would then press the button. So when I press the button, it'll start making a noise and vibrate. And then when you place a different weight on it, it turns off. And then when I let go, it'll start. And so what that's simulating there is whenever the dog jumps on it, it'll make that noise and vibrate. When they jump off, it'll stop. And the benefit of this device is that it isolates only the couch itself. So your dog can sit next to your couch, in front of your couch, and it'll be fine. My main competitor wouldn't be allowed to do that because it creates an invisible fence around your couch. And so the dog will be punished just for walking by the couch. Especially if you have a small apartment like mine with myself, that just wouldn't work out very well. She wouldn't be able to get into it. So this is my prototype, and my company Alpha Mutt. Thank you. If anyone has any questions.
How tunable is the weight so far? What if my kid weighs about what my dog weighs?
Yep. So that's what I'm looking for help with. I have two solutions to that problem. One is to incorporate an accelerometer into this device, and so if this device jumps suddenly, it knows that the dog just jumped, and then in addition to that, if the couch then weighs that the dog's weight is on it, then more likely than not, the dog is probably on it. I would then like to introduce a proximity sensor. So those are three check boxes. So like if the dog is near the couch, if the couch weighs the same weight as the dog, and if this accelerometer is jumped recently, then more likely than not, the dog is on it. That's my biggest concern is that, but I think I found a solution to it. It's just implementing that into my printed circuit board is a little bit more difficult because that's not my strong suit, it's not my background. But I did recently design a board that incorporates an accelerometer, and it should be here sometime this week. I'll be attempting to program it, test it out, and see how that works.
How long does the batteries last on
To be honest, I haven't tested that out yet. Right now, I'm more concerned to see if it even works. But yeah, that's going to be so you have to recharge the battery every day. That's not going to be that would be good. Yep.
What is the platform you're using currently?
So currently, all of this is developed using Arduino IDE. So if you were to look at these boards here, they're all Arduinos. But even this board here is technically an Arduino. It has an Atmega 328P chip, which is an Arduino pretty much essentially. And the same with these boards here. This probably looks nothing like an Arduino, but it is. Like I designed this board with an Atmega 328P chip there as well, because that's all I know. I don't have any background in programming or like printed circuit board design.
Right.
So I stick as close to Arduino as I can, because there's tons of resources online. And that's my limiting factor, is that I would like to design a board that's inexpensive to manufacture. But again, that's a little bit more complex than what I'm used to. So,
What's your price point?
price point as of right now, I'm estimating it to be around anywhere between $50 to $100. I'm envisioning selling this device at like a furniture store instead of. I could also sell it at a pet retail store, but I'm envisioning selling it at a furniture store. And the logic behind that is, when you're going to the pet store, you're not going there. Usually not going there to spend like $100. You're going there maybe buy some toys or some food for your pet. When you go to furniture store, you're investing in a big investment. You spend anywhere from $1,000 to $5,000 on a new piece of furniture. And if you're about to cash out, and the cashier tells you like, hey, do you want to protect your new furniture from your pet damage for $100? It's like a no-brainer. It's like, yeah, $100 in relationship to $5,000 is nothing, but $100 in relationship to a dog toy, $5 is a big round. So I'm envisioning selling it at the furniture stores for anywhere from $50 to $100. Yep.
So it's an AlphaMutt innovative product. What other products do you envision?
Yes, so I'm glad you asked that. So there's another device I'm planning on implementing, which is a device that trains pets to stay on a certain level of a house. So say, for instance, you have a 2-story house and your bedrooms are all upstairs, and you just want your dogs to stay on the first floor, your cat's on the first floor. It would be like a parametric sensor that you could also purchase and would communicate with the same collar. So it's more of like it would train the dog to stay on that level. So it's kind of like a family product. You would buy this collar device, and then you can then buy all the sensors that you want. So you would buy sensors to keep them off the couch or the bed, sensors to keep them out of the first floor, out of the second floor. I also have another device that trains dogs not to pull while we walk on a leash, and that sensor communicates with that collar as well. So it's just like a family of sensors that then communicates with one collar. So that's the vision. And then there's tons of other products that I'd like to roll out with as well, but those three that I just mentioned are primarily focused on this device. Yes?
You said pet, but does that include other pets?
Yeah, I'm envisioning primarily dogs and cats. If you want to keep like your gerbil off the couch, like this would work too, but like I'm envisioning primarily my target customers are dogs and cats.
You have anything you'll train my kids?
Your kids?
Have you considered Tom as a furniture maker? See if you can integrate it as part of the.
Yeah, so that's like a different I have many business models, and one of them is that where instead of developing a whole product around my company, this device I currently have a provisional patent application for it. So I could go to a furniture manufacturer and tell them, hey, I'm going to license this patent to you, and you would incorporate it into your smart furniture, and then I wouldn't have to really do much. I'll just collect royalties. So that's an avenue I could take.
people that have multiple pets.
Yep. So myself, I have 2 dogs, and my 2 dogs, fortunately for me, weigh dramatically different than one another. So if my big dog jumps on this, it would detect 75 pounds. It would send a signal just to her collar. If my little dog jumps on it, it would detect 25 pounds, and it would send a signal just to her collar. So it can be used to train multiple pets. And then the benefit of the buzzer, the noise making, and the vibration is that, say for instance at night, you leave your bedroom door open and you're sleeping in your bed and your dog jumps on it, you can turn the buzzer off and just leave the vibration on, so it's like a silent mode. So it won't really wake you up, as long as the dog doesn't jump on you, of course, but it would just, I think that's a good feature for that as well.
Questions, one more?
So did you do anything with like precision geofencing? Anything like that?
No.
All right, I just wanted to ask. Thanks.
What is precision geofencing?
So I mean, like with beaconing. So like I was wondering, like you could potentially have, if you had 2 dogs the same weight,
Yep.
right? Now how do I trick it out? So rather than just like, it's a proximity sensor, but it'd be very specific to the height and space of the couch.
Yeah, yeah. I'll be interested in looking into that. But how you would detect between the 2 different dogs is the accelerometer. So like if one dog just recently jumped, then we would fix that. But my main goal is to just isolate the furniture itself. Like imagine if you live in New York City and you have a really small apartment, and I'm not sure how accurate the geofencing is. Like if you can just do like this corner to that corner to that corner, but like my biggest concern was to make sure that my biggest focus was to make sure I only focus on the furniture itself and not create this invisible barrier that they can't see.
Yeah, yeah.
Because that requires a lot of training for them to understand, like, when I get past this invisible fence, like, I'm going to get punished.
All right. Thank you. All right, next up, we're going to have Tom, who is the local Cloudera guy, although he keeps telling everybody he's never here, because he's always someplace else.
Yes.
But he's going to introduce the next speaker, and we're going to talk a little bit about big data, Cloudera, with Apache, I'm blanking.
Apache everything.
Apache Impala, yeah.
Or Impala, okay.
So, take it away, guys. Yeah.
So I'm a local Cloudera here. I've been working for companies, very innovative companies out of the Bay Area for quite some time. So just back to Tim's point, I'm generally never here. And when I do come here, I have to follow up that guy once. That was a pretty amazing talk, by the way. I was pretty impressed. I could see you probably going on Shark Tank or something like that. That was really good. The reason why I work with Cloudera and I like the local communities is, first of all, just getting out here, talking, hearing what other people are doing. I could probably have a conversation with Jordan, maybe over beers if he's 21 or over. I don't know that yet. And just have those ideas, bounce those ideas off each other. The reason why I like Cloudera is when I'm talking to people in the community, I can really talk about very progressive things. So what Cloudera is doing is, I would say, next generation data platform. You start working with things like machine learning, artificial intelligence, deep learning. And so what Cloudera is doing is they're taking the same technology that came out of Google and Facebook and all of these companies, and because it's open source and it's very collaborative, you're able to do these advanced things and really just build on top of each other. And so what you end up with is a data platform that can run anywhere. It can work with any kind of data. And you think Jordan's use case, for example, what if he wants to start collecting all that data and making it available in real time so somebody can log into a website and see how many times is my dog jumping on the couch? Is he learning? Is he jumping on it less and less till eventually he learns, don't jump on the couch anymore? Where, take a barometric sensor, where is he at within the house, right? So really, your imagination is what limits you. And so if you can think it, right, and you used to think, wow, that's amazing, it's impossible. Well, what Cloudera is doing, the reason why I like Cloudera is we're taking what's impossible today and really making it possible tomorrow. And so I want to come out here and do a talk, but I've had some conversations with a Lehigh alum, and I said, Derek, you have a really good way of presenting the concept, and since you're from here, maybe I can connect you with Tim and we can get Derek out here. I'm glad, months and months of talking about it, we're finally able to make it happen. So, Derek, come on up.
Hi guys, I think we'll give me a second here to get hooked up.
This should work. My name's Garrett Payne. I'm a systems engineer, much like Tom is. I've been a data geek for 20 years. I love being a data geek, and my favorite part about my job, similar to what Tom said, is working with my customers and helping them take their data problems and turning them into something valuable. So what I'm going to talk about today is I'm going to give you a background on Hadoop. I'm going to go in depth with a tool called Apache Impala. I have a couple brief videos just so I can keep you guys awake. Can everybody see that okay? All right. So it's really nice to be here at Lehigh. I haven't been back in a few years, and as Tom said, he talked to me about coming back here, and I always love a chance to come back. I hope you'll permit me just one moment, because I had the pleasure of bringing along my dad, who's sitting in the back, Don Kane, who's also a Lehigh grad.
Wow.
And it was really nice because I've never had an opportunity to speak in front of my dad before, so no booze, okay? But it's great to be here. It's a thrill to come back to Lehigh. Every time I come back, there's like new buildings popping up. So anyway, I'm a data guy. I work for a company called Cloudera, as you heard from Tom. Cloudera, has anybody heard of Cloudera before? Just show hands. If you haven't, that's okay. Okay, good. How about Hadoop? Anybody heard of Hadoop? Even more hands. That's good. Okay, so Hadoop is an open source technology. I'm going to talk about what Hadoop is. I'm going to give you some background on the components. I'm going to tell you some ways that some people are changing things in the world with Hadoop. I believe it's a game-changing technology. Before I joined Cloudera, which was about 2 years ago, I was the lead architect at JP Morgan, and my job was to evaluate technologies. It was to listen to people like me, hear all the sales pitches, evaluate all the tools, figure out what was real and what was just hype. Hadoop is real. It's here to stay. Gartner estimated that by 2020, 100% of the Fortune 500 will be using Hadoop. 100%. So that's a pretty bold prediction. The point is, it's a technology that's here to stay. It's real. People are doing real things about it. If you've ever used Facebook or LinkedIn or Google or Yahoo, you're using Hadoop, whether you know it or not. So I'm going to get into some details about the technology as a whole. I'm going to do a demo at the end. I'm going to talk about SQL on Hadoop. How many people in the room would consider yourself SQL people, or able to write SQL, select statements a little bit? That's okay. You're familiar with SQL. All right, good. That gives me some background. So let me start with Cloudera first. Cloudera is 9 years old now. I guess we're considered a startup still. We were started by former employees of Oracle, Yahoo, Facebook, and Google. And basically, it was a handful of geeks that were doing data technologies in their jobs. The creator of Hadoop was creating Hadoop because he was trying to solve a problem at Yahoo. Have you ever heard of Lucene? Anybody heard of Lucene before? Yeah? So if you've ever been to any website that has a search bar, you're using Lucene in the background. It's like 95% of websites use Lucene. And it's an open source search and index technology. Well, the guy that created Lucene at Yahoo is named Doug Cutting. And he was looking on how he could build Yahoo. He needed to index the entire web. Well, that's not an easy thing to do. And you don't just throw it all in an Oracle database and pay like $20 million. So he needed something that was scalable. And I'm going to get into some details on why he did that. So Cloudera was formed around the idea that Hadoop has value to large enterprises. It has commercial value. So the company was formed by some folks here. We work in every industry. We have support organizations across the country. We train more than anyone in the world on Hadoop. And we have more than 2,300 partners. So if you're using tools today in your IT groups, tools that look at SQL or any type of data, odds are highly likely that the tool you're using will interface with Hadoop in some way. So it's very applicable. We also just went public in April, which was a big win for us. For me, I did the same job from one day to the next, nothing happened. But for a lot of people, that was a big thrill, and it was a really cool thing to see the company go public on the New York Stock Exchange. So let me talk about open source software. You've all probably heard of open source software. Why is open source good? Am I using this mic?
Yeah, I hear you.
All right. So the thing that's great about open source is open source got its start 25 plus years ago. It's probably older than that. But the first time I ever saw open source was the Apache web server. That was one of the biggest things a lot of people saw. Or it was Linux. And a lot of times people would look at open source, they'd say, well, I don't know if we can use this. We can bet our organization on open source software. But things have evolved. Now Apache, or Apache Tomcat, runs more web servers than anything else in the world. And Linux is on more servers than anything else in the world. So clearly, the industry, the world, has proven that open source is good. So it's good because you can evaluate for free. You can just go and download it. There's freedom from lock-in. No vendor owns open source software. Same way no vendor owns Hadoop. And it's scalable innovation. We have developers donating their time around the world to build features that they're passionate about. So open source is clearly here to stay. If you're familiar with Linux, and you all probably are, you know that you probably are using one of these distributions over here. Well, these are distributions wrapped around a free open source product like Linux. Now, you could go and just download Linux, the kernel, and start playing it yourself, but you probably don't. You probably use one of these. These are distributions of Linux, Red Hat being the most popular. And Red Hat was the first company that built a successful commercial organization around an open source technology. Cloudera is a very similar model that took Red Hat. So the same way Red Hat took Linux and sells software and support enhancements and management tools and security, Cloudera also does with Hadoop. Okay, so why do you want to use a distribution rather than just downloading the software yourself? Well, it's stable. You know, there's an organization behind it that packages every release. There are regular upgrades for the same reason. And you can go to an entity, some organization, to pay support. Now, if you're an organization like Lehigh, you might have hundreds or even thousands of Linux servers. You probably want somebody to call because your business is not Linux development and support. So that's the way a lot of organizations will look at this, is I need somebody to call if something breaks or there's a bug, and there are. So why do we use a distribution? Faster time to market. We get a couple of releases a year. Again, I'm just talking about open source technology as a whole. We minimize our risk as an organization. You know, we don't have to own the problem. We can lean on someone, and we can focus on our knitting, right? Our own business problem. What problem are we going to solve for our organization? We're probably not in the open source software business. So this allows us to stick with that. So if we look at the Hadoop ecosystem, these are some of the things you might have heard of before. These are Hadoop ecosystem projects. We call them open source projects, but they're products. These are the products that Cloudera develops and packages and supports. So if you're talking to Cloudera, you're getting 26 open source products. Not even all of them are listed here. But you get to lean on that entity, and we develop those products. So if you look at what we call CDH, or Cloudera's distribution, including Apache Hadoop, you have a number of those projects you just saw. And the core, everything that you see here, is an open source solution. It's free. You can go and download it. But we bundle it together and we package it. So if we look at why Hadoop is interesting, this is the biggest thing you can remember. If you're a technologist and you're looking at solutions like Hadoop or something else, you need to find your fit for purpose. So Hadoop is just another technology, but unless it solves a problem that meets your needs, what good is it? Any technology is like that. So I'm not going to tell you that Hadoop solves the world's problems. It doesn't. But it solves some very specific problems and many, many problems because of the number of open source projects you see in it. So, anybody know who this guy is? This is Hadoop. This is the original Hadoop. He's a stuffed animal. He is a purple elephant, or excuse me, yellow elephant. I got focused on my show shirt, which I heard was a little loud, but I don't care, I like it. He is a yellow elephant. So if you ever see the Hadoop symbol, this is the reason why we have an elephant. And it came from Doug Cutting. This was Doug Cutting's son's stuffed animal. And Doug, who was working at Yahoo, was naming projects. Well, if you've ever created a product and you had to avoid a copyright infringement problem, you needed to come up with a new word, which is why we've got so many amalgams of strange words for companies these days. Hadoop was the nonsense word that his little boy gave to his stuffed animal. He said, that might make a good project. So as he was creating Hadoop, that's where he needed it. So I'm going to play a brief video for you. You'll hear from Doug Cutting, the co-creator of Hadoop. He's also the chief architect at Cloudera, and he's going to tell you a little story about it.
This is Hadoop's 10-year birthday. Hadoop's a 10-year-old. I'm Doug Cutting. I'm a software developer. I'm a dad, I'm a husband, and a cyclist. I was born here in the Napa Valley, lived lived here most of my life. Dan grew up right here on this lot. 96, I think we got married, so 19 years. At its simplest, Hadoop was a way to take a bunch of computers and make them appear as one computer to software. There's two things that people mean by Hadoop. Apache Hadoop, which is a project which has some defined functionalities, and then people use it more generally to talk about this whole set of technologies that are built around it. And my son had this yellow elephant toy, and we would hear him calling it Hadoop. And then at one point I realized, wait a minute, that would be an awesome software project name. I'm pretty tickled by all the uses I hear about. We're seeing people save lives. Hospitals are reducing their sepsis rate measurably. The neonatal ICUs, improving the care of premature babies. My dad found his wife through an online dating system that used Hadoop. To him, that's the greatest application of Hadoop ever. In the early days, it was primarily a guy named Mike Caffarella and I were working on this stuff. I certainly didn't imagine that Hadoop would succeed the way it has. In fact, when Mike Olson first approached me, when they were founding Cloudera, I was not interested. I didn't believe that folks outside of Silicon Valley would ever take Hadoop very seriously. But he, from the beginning, was like, this is going to be a billion-dollar industry. It's going to grow in this way. And everything he said has come true. He thinks the secret was getting Ian involved. And so Hadoop I created as open source because I had been working in open source already and realized the power of open source to create standards that everyone shares and that can grow to dominate because you've got more people contributing, making them better. People are more comfortable adopting these technologies that aren't controlled by a single institution and that outlive vending companies and are really controlled by the communities that use them. I think Hadoop's in the adolescence of its life. I think it's going to be around for decades. It's the product of a community, and I want to thank everybody out there who's done their part in making this succeed. What a 10 years it's been.
So that was Doug Cuddy, creator of Hadoop. You may have heard the original name for it. It was called Nudge, and then developed into Hadoop. He actually shared a conversation with me once about how his conversation went with the folks at Yahoo. He's like, hey, I created this open source technology. I think I'm going to open source it. What do you think? And Yahoo was like, yeah, it's probably not worth much. Go ahead. So now it's used worldwide, right? So the core of Hadoop is what we now call core Hadoop. There are a couple components, and I'm going to get into some of the technical pieces of this here. This is what we call core Hadoop. There's three main things. HDFS, the Hadoop Distributed File System. That was the game changer that made Hadoop amazing. Because it was basically taking a cluster of data and spreading it across many servers. So as you're building a very scalable solution at Yahoo to index the whole web, you need something that builds failure into the equation. It's got to be scalable. It's got to be resilient. It's got to scale to a monstrously huge scale and be able to still work. So the core of Hadoop is HDFS. And HDFS is how we take the data and spread it across many nodes. Now, a couple key differences exist here, and I'm going to get into more details on that, but it's big blocks of data. It's fast reads, so it's a very different architecture than traditional relational databases, and this is why it's different. Relational databases are very good at storing data, they're good at transactional systems, and then as you move into data warehousing, it's about analytics. It's larger, readable sets of data. Hadoop is more about the latter, but it's in a different way. It was designed as an append-only file system. So you take all your data, you store it very cheaply on either inexpensive servers or inexpensive storage in the cloud, and then you read it. You read it really, really fast at huge amounts of data because you have an army of servers, maybe it's 10, maybe it's 10,000, working together. And as of today, we still have not found a theoretical limit to Hadoop. I think some of the largest clusters are in the neighborhood of 10,000 servers in a single cluster. We have customers with 5,000 or 6,000 nodes. Companies like Google, LinkedIn, Facebook, they do their own thing. They don't even work with an entity like us. They have hundreds of Hadoop people. So that's where you see some of that scale. Now, most of us don't deal with data on that scale. We might deal with handfuls of terabytes or even a petabyte for our whole organization. But if you think about how you might scale and bring these pieces together, this comes into play. You may have heard the term data lake or data hub. Those are terms that we use. You may have also heard a term called data swamp. That's what we don't want. That's when we just throw our garbage and it just turns into a swamp with no organization. So as we look at HDFS, that's how we're spreading the data. And it's also designed to be resilient. So I equate it to software RAID, if anybody's familiar with RAID, I would call it software RAID to some extent. MapReduce was the processing engine, is the processing engine. That was the 1.0 version of how we process data on Hadoop. Both of these are written in Java. So in the beginning, if you were going to use Hadoop at the scale that Doug was doing at Yahoo, you were writing Java code. You were writing MapReduce jobs. And you were processing the data in these large data sets on your cluster. Well, Yarn came into play because people that were writing jobs were starting to clobber each other. They needed prioritization. They needed somebody in charge of the farm. Yarn is your job scheduler, your job manager, to make sure you can set priorities and pool resources. So that's the core of Hadoop. Any questions before I move on from there? Okay. All right, so when we look, this is a pretty complicated diagram. When we look at a big data cluster or a Hadoop cluster, these are some of the things we see. At the top left, there's sort of two core components of what we consider a server. When I say node, we mean servers. We have workers that are the ones doing all the jobs, they're storing the data, and there's various pieces depending on what you run. And then there are masters. Now, the masters generally start with 3 servers, but the core of this is the name node. The name node is like your dictionary. It's where all of the blocks are located. So if you're an application and you want to call data from Hadoop, you're calling the name node and saying, hey, where's that file? And the name node said, well, it's spread in all these pieces across all these servers. That's the name node. And just in case the name node fails, we have a secondary name node, or a standby name node. So when you run a cluster, these 3 at the top are sort of standard. No matter what size cluster you run, you're going to run 3 nodes that have some of these core master or server components here. Make sense? And then gateways are sometimes we see if you're doing data load. Sometimes people might call these file drops or drop points. This is when you're bringing data into a cluster from some other application. You may use a gateway, you may go direct. But the good part about this is if you're an application or you're a user doing analytics or data science, you're going to call the cluster as one. You're going to call that one service, and you're going to work with all of those servers at the same time to do what you do, using those basic calls under the covers. And the service we use to run it all is called Cloudera Manager. So I mentioned Cloudera is a hybrid, kind of an open source company, much like Red Hat. We have components that we have created to manage. Cloudera Manager manages all of these things that you see here, which if you can imagine, well, let me step back a second. If you look at open source technology, open source products are created by different people around the world. Different designs, different architectures, different UIs. They all have their own way of logging. Every project is different because people create them on their own. So you can imagine what a nightmare it would be if you were managing all these individual components. So Cloudera created Cloudera Manager, which is the leading management tool in the market today. So it manages all of these moving parts at a single console, one pane of glass. And it also manages, I think we're over 2,000 parameters. And it's self-tuning, so it'll guide you and help you run all these clusters. Well, I see you in a lot of MapReduce jobs. It's taken, you need more memory. Why don't you change your memory and increase the Java heap size? Things like that, makes it easier. All right, if we look at what HDFS is, this is how we spread out the blocks. So we have our main node, and if we're going to bring in a file, for example, file 1, we're going to spread the file across multiple name nodes. Now we're usually going to do it in 128 megabyte blocks, very large blocks. If you're familiar with a Unix server, you probably see 32K, 64K blocks in that area. This is radically larger than that, exponentially larger. But the point of storing the data in large block sizes is to get fast read speeds. So Hadoop is a slow write type of a process, but very fast reads. And that's why it was designed that way. It's also why you would not use Hadoop as a transactional database, right? So when you think about your fit for purpose, you say, well, why don't we just take our HR application, we'll take it off Oracle, let's put it on Hadoop. Well, you would never do that because it's not a transactional database. Use the technology for the right job. So these are some of the core products of the Hadoop ecosystem. I'm going to talk about a few of these today. Spark, HBase, everybody's probably heard of Spark. Some of you have. Spark is the next generation engine for Hadoop. It's replacing MapReduce. MapReduce will be around for many years, but Spark is a faster in-memory engine. HBase, Hive, Impala, some of these other things, I'm going to talk about some of these. So what do you put? What is this Hadoop bucket? What can I put in Hadoop? Well, you can put anything. It's not a relational database, so it doesn't really have a structure. It's like a Windows file server. You could throw in there whatever you want to. So you could put XML or JSON, you could put text, CSV. Avro and Parquet and Orc are three different specific file formats that we often use on Hadoop. You could put images, you could put video, you could put whatever you want because it's an open structure. And those same 128 megabyte blocks will be replicated. Generally speaking, there's 3 copies of every block of data across the cluster. So if you lose a drive, you lose a server, you're fine. Make sense? Okay, so as we look at some of the concepts, here's an example of where file storage works. If we take a large file, let's say this is a 1 terabyte file, and we're going to break it up into blocks. Well, the first block, again, is probably 128 megabytes, is going to be placed in multiple servers. So we have 3 copies. We always have to have 3 copies. And again, the core tenet of Hadoop is that you design for failure. Servers are going to fail. Disk drives are going to fail. Even cloud storage is going to fail. Anybody remember the huge Amazon outage a couple weeks ago? Like half the websites went down because they had storage out there. You've got to design for that. And many of them were using Hadoop, but that was just massive scale. But you have to plan for failures, disaster recovery, things like that. So how do we get data in and out of Hadoop? There's a number of different ways. Sorry about the formatting. Unfortunately, I think it's the resolution here. There are a number of different things. If you're writing an application up top, you have puts and gets. That's kind of the basic low-level way. You put a file, you get a file. Very straightforward. You can use calls from Java or other languages, and you're putting files in the file system. Flume. I'm going to talk a little more about Flume. Flume is a log ingestion system. Flume project, excuse me. So if you're ingesting log files, transactions from many, many systems, and they're streaming in, Flume is the way you might do that. This is the one I see the most, Scoop. If you can read it, it's S-Q-O-O-P. I don't know why, but it is. So Scoop is the way we use relational databases. Now, most data with my customers, I would say in the neighborhood of 95%, they are using structured data from a relational database. They're just doing it at big scales. They're saving the entire history of that database. They're saving every transaction, very granular details, because one of the great benefits of Hadoop is it's cheap. It's often 10 times cheaper than conventional data technologies with SAM and expensive software licensing. So you're able to save data in a way you were not before. That's cost effective. And then the last one is maybe visualizations or BI tools or any other way you want to do it. But the point is there's many ways to bring data in and out. So Flume and Kafka, I mentioned Flume, that's the log ingestion file. If you're going to bring in log files, sensor data, IoT, Internet of Things. Anybody heard about IoT? A lot of people are talking about that, right? Sensor data in your car, maybe your watch.
Your dog.
Your dog. You might be doing IoT. You might be using Flume or Kafka. This is continuous flow of data. We most often see this with log files. I have a customer that's using Flume to ingest, it's a grocery chain, to ingest every single transaction on every register in the world. Every single transaction in real time. They're using Flume and Kafka to do that because they want up-to-date information about their inventories, about what's selling, what's moving, when they're judging by weather patterns changing. Do we stock up on batteries and milk when it's about to have a thunderstorm? Things like that are things that they want to know about. Kafka is when we start to move Flume. Flume is a very simple, easy to set up tool, but it's not very large and scalable. Kafka gives us a lot more flexibility, a lot more resiliency. So we often see Flume and Kafka together, which people call Flafka. As techies like to make up names. So Flume and Kafka is Flafka. If you ever hear that, that's what it means. Scoop I talked about with relational databases. So RDBMSs, Oracle, Sybase, SQL, DB2, Postgres, MySQL, Maria, these are all solutions that you can use with Hadoop to send data in or out. And that's often where people start. Well, I have an enterprise application and I want to do reporting on it, and my data warehouse is too slow or too expensive. How do I do it? Well, we can set you up very quickly with Scoop, drop it in Hadoop, and then you can use one of our SQL tools to do reporting on it. That's often the first use case that people do with Hadoop is eliminating data silos. How many of you, show of hands, in your organization have lots of different databases that you have to touch in order to gather data? Yeah? I have yet to meet a customer that doesn't have that problem. Is Hadoop the solution? Yeah, it could be one of them. And it's great because it breaks down the silos of data. Usually it's ownership or it's security or it's performance that people are worried about. You can do this, and OfficeScoop is the tool used to do that. JDBC and ODBC, if you're familiar with those, that's how we connect to any database today with a BI tool or reporting tool. Same thing here. We use Scoop to do that. Connect to database. So Spark. Why is Spark unique? If you are going to, I know that we have some students in the room, if you're thinking about what is the next thing I should learn, this is your safest bet. This is your most marketable skill that you could attain right now. Spark is the next generation data processing engine for Hadoop, or even non-Hadoop. So when people started to use MapReduce is a great technology. It's now 10 years old, but it's very I/O intensive. It uses a lot of disk, a lot of input and output. So MapReduce takes about 30 seconds sometimes to spin up a job. Well, I need a data set, and I'm going to put it in a dashboard, and if you're using MapReduce, well, I don't know if 30 seconds is fast enough to deliver that data. So the other thing that changed was memory got a lot cheaper than it was 10 years ago. Now people have tons of memory in their servers. So Spark was the technology we brought into play to help move that along. So Spark takes advantage of memory, it takes advantage of processing, and it's generally speaking 1/4 the number of lines of code you have to write, so developers love it. And here's how they're using it. Machine learning, interactive analytics, batch, business intelligence, algorithms, anything that's modern and moving forward with data science is generally going to be used in Spark in some way. Maybe it's R or SAS, but Spark is probably in the mix. Spark Streaming is a real-time version of Spark. Still uses the same code base. And the great part here is if you're doing batch work, overnight batches, maybe you're doing machine learning algorithms, you can use Spark. Maybe you decide you need to move to real time with the same jobs. You can move to Spark Streaming with a minimal amount of changes to your code. Same code base. Oftentimes people will call this micro batch, but it's sub-second batches. Okay, let me move on to Hive. So I first got a look at Hadoop about 6 years ago, and I said, so what? I'm a SQL guy. It doesn't mean anything to me. And then I started to look at Hive. Hive opened up Hadoop to SQL. It opened it up to reporting and analytics and business intelligence folks. It said, now I don't have to write Java anymore. Hive is SQL on Hadoop. So it uses a language called HiveQL, which is ANSI SQL compliant. And this is the 1.0 version of SQL on Hadoop. This is how a lot of people started to use Hadoop. You use it to write SQL, you use it to write ETL jobs. When you're moving data in and out of Hadoop, or you're doing transformations, maybe with ETL tools, you're probably going to be using Hive. Hive can use underneath it MapReduce, which I talked about before. It translates that SQL code into MapReduce code, and it can now use Spark. Cloudera created the development underneath Hive to use Spark, so you can now run Hive on Spark, which is faster. So things changed with that memory change. Memory got really cheap, and people started to say, I don't want to wait 30 seconds for a dashboard. I can't. My users will not tolerate it. So Cloudera created Apache Impala. It's another SQL engine on Hadoop. Well, why do we need two? I'm going to tell you why. But Impala takes advantage. It was written in C. It takes advantage of that memory. So you don't have that 30-second lag time to spin up those big jobs. So Impala opened up data visualization. It opened up dashboards that were fast. It does not use MapReduce. It's massively parallel. It's based on Dremel, very low latency. So if you need to get the data in a second or less even, you're going to use Impala. That's your SQL engine to pull the data out, and Hive might be your SQL engine to put the data in. Search, or Solr. Anybody heard of Solr? Solr relies on Lucene. I mentioned Lucene before. Parts of Lucene are in Solr. Solr is your search and index application. So if you're indexing data and you want to deliver it, maybe you want to index it and deliver it in a Google-like fashion. You've got an open search box. You might use Solr to index that data under the covers. Integrates with HDFS, MapReduce, a lot of different projects. So people are using Solr to index and search the data, and often they're delivering it through another tool that we call Q. So here's an example of a tool using what we call Cloudera Search, which is Solr and Libby and a couple other things. This is another open source tool called Hue. And I know you can't read the detail, but the point is that the structure of this web page probably looks a little familiar to you. On the top, you see a search box. In this case, we're searching tweets. for searching Twitter results. On the left, you see what we call facets. So if you want to filter the data set on the screen, you might do that. You might do this with Amazon every day, but this is just a sample data set. Down here we see our details we've chosen to filter or search on, and then this is just a quick and dirty simple bar chart. So this is an example of Solr behind the scenes and Hue, an open source user interface, Hadoop user experience to deliver data. Let's get past this. HBase. If you've heard people talk about NoSQL, anybody heard NoSQL, Cassandra, Mongo, HBase? They're the same family of products. They're columnar data stores or structured in columnar formats. And there's some different architectural differences in those tools. Cloudera supports HBase and develops HBase. So this is the solution that you use when you're delivering very large amounts of data over a user portal. Maybe you have customers on your website and they want to see their complete transaction history. You might be using HBase. Well, why would we use HBase and not something else? Think about your fit for purpose. The benefit of HBase is scale to support very, very high throughput. And that's key. You've got to look at the technology that fits the bill. So millions of inserts and updates per second. So this is a faster way. Tom, you want to add something?
Just say one of the biggest use cases for this is Facebook Messenger.
Facebook Messenger, thank you.
It's
So,
built on HBase.
and the key here is random scans. When you're doing HBase, it's good at random reads. So again, another technology. Kudu is one of the recent additions that data geeks like me are very excited about. So we have Hadoop, and there's benefits using Parquet, things like that. This is one structured format. On the other end of the spectrum, we have HBase, that low latency. Kudu fit a big need in the middle of the open source market that was missing. And these are updates. If you remember anything about Kudu, it's fast updates. So if you're bringing data in from a lot of data sources, and those data records are changing, you want to do updates. Well, Hadoop is not designed to do updates, and HBase is not optimized for it in the same way. So Kudu is a new open source project that we released a year ago. It just hit GA. That's fitting the bill. Kudu was so popular, Cloudera was shocked. We had 100 people in production with a beta. We had never seen that before. So Kudu was still in beta, and there were companies running it in production for large workloads. So that gives you more like ACID, more database type transaction workloads. Fast updates. Any questions so far?
One quick question. Earlier you mentioned Hadoop itself is not well suited for transactional areas, right?
Yes.
So the grocery store example that you were giving, so is that in parallel just storing the transaction, the records for post-processing, or how is the transaction part of the grocery?
It's more transactional in that you can receive transactional updates. Similar, it's closer aligned to a data warehouse. So let's just say you have a customer database, and you're constantly getting updates on address records. You could store the customer database in Hadoop, but if you have to add a new update for a record, you might need to write a new set of data. Well, that would be very cumbersome, especially at large scales. Kudu, in the way it's stored, allows you to do those updates at a faster rate, similar to a transactional database. Yeah, Tom?
And Kudu and HBase are ACID at the row level. So as long as you're manipulating one row, you do get ACID.
That answers your question.
I was still wondering that the grocery store example that you gave, so is there a Kudu component to it, or is there an HBase component, or was it just a Hadoop example?
I may have oversimplified. The grocery example actually has a lot of pieces in the mix, but I was referring to the ingestion using Kafka and Fluent. Yeah, they actually use HBase. They don't use Kudu because it wasn't out when they created it. They're using HDFS, they're using Hive and Solr. A lot of Spark. Okay, let me get back to this. So Kudu, so key use cases in Kudu. Why is Kudu important? Time series data, this is the big one. Lots of updates come in for a certain data set throughout the day. Maybe we want to save all of the time series, we want to do those updates throughout a transactional day. Machine data analytics. So here's a big one we see, network threat detection. We use Hadoop for a lot of cybersecurity solutions. Kudu, again, is great for that. Maybe we're monitoring websites. We're monitoring your desktops to make sure you're not doing anything you shouldn't. We're monitoring external sites or external elements to do this. And then online reporting, operational data stores, change data capture. These are things that are all good, really good fits for Kudu. Okay, so data science is a growing area. When I started working on Hadoop, I thought of myself as a data scientist. I was not. There's a lot of data scientists that know that they're data scientists, and there are many people you might run into that think they're data scientists that really aren't. They take it very seriously. Data science is the pinnacle of data manipulation. It is as far as you can go with data science. The good part about data science is it's getting easier because the tools are getting better and better. I know it'll come as a surprise that Cloudera has a tool to do data science, Cloudera Data Science Workbench, so if you're interested, grab one of us after the meeting. But the key here is what's happening with machine learning, predictive analytics. It was data scientists, but the skill level to do this is going down and the frequency is coming up. So the cost of computing the resources, data scientists need access to vast amounts of data to run their algorithms, to build their data products. Well, and if you ever talk to a data scientist, they'll tell you a couple of things. One, I don't have enough data to do my job because IT won't give it to me or it's too expensive or whatever. And two, it's hard to deploy my product. So data scientists create these great applications or algorithms or data products, and they have to get them or productionalize them. That's one of the big challenges they face. Cybersecurity is a huge problem for everybody. You can read about it in the news every day. Someone was hacked. How do we do it? Well, there is a great new product that's already won some awards that Intel co-created with Cloudera called Apache Spot. It's an open source product. So what is Apache Spot and why is it interesting? Well, these are companies that are involved with Apache Spot. But what it is an open data model for cybersecurity. So if you think about the amount of dimensions that exist for cybersecurity, there's hacking, there's denial of service, there's email phishing attacks. There are so many different things that cybersecurity touches. And if you were to go into the marketplace and buy a solution, say for Lehigh needed an anti-hacking solution, Lehigh would have to talk and buy at least 3 or 4 different products to do various pieces of the puzzle. The great benefit of Apache Spot is it builds a model that is scalable, that companies can create and contribute to, that you can create and contribute to. Well, I'm really good at ingesting Cisco NetFlow data. So I'm going to build a model to go into Apache Spot so that anybody can ingest that data in the world. So this opens up cybersecurity to the open source world. It's a game changer. Is it young and immature? Absolutely. But 5 years from now, I think we're going to see most people using Apache Spot or something like it to do cybersecurity. Sentry is a big part of the open source security solution. Cloudera embraces Sentry. It's another open source solution. This is role-based access control. So this is how we control who sees the data in that data lake or that data hub. Because if we throw it all in, everyone's not allowed to see it all. So we often have conversations with info security people or CISOs and say, whoa, you can't just give everybody keys. You're right, we can't. We use Sentry. And if any of you are using Active Directory in your organizations, you sign in with a Windows logon, we're going to use the same credentials. We're going to use your users and groups. Maybe you're part of the sales group or the IT group. We're going to use the same security you already have in your organization. We're going to feed it in Sentry, and we're going to use Sentry to control the open source components. So that's how we can control everything in this data hub. Skip over this. Encryption is also available. If you want to encrypt the data, you have open source encryption available. You can encrypt your data within it. This is a big one that comes up a lot, is redacting log files or redacting data. With Hadoop or Cloudera's distribution of Hadoop, you can redact the cluster, the whole cluster. You can set a policy that says, if there's a social security number and it meets the 3, 2, 4 parameters and it's a number with a regular expression, we're going to redact it, meaning we're going to mask it and put all stars if anybody tries to read the data. So that's big, and we can set it at a cluster level. Social security number, addresses, customer numbers, whatever you want, you can set it at a cluster level. So all the open source projects that I talked about that are touching that would be subjected to those rules. MasterCard, we all probably have MasterCard in our pockets. MasterCard and its industry has a standard called PCI certification, Payment Card Industry Certification. And that says, there's a number of rules, but it says if you handle an individual's credit card transaction, you have to meet all of these security standards. Cloudera is the first and only PCI certified big data platform. We worked with MasterCard for 2 years to build that certified platform because MasterCard deals with billions of transactions a day. It has to scale, it has to be up, it has to be secure. So this was so successful that MasterCard launched their own business to help other vendors, other customers, even competitors, set up PCI certified clusters. So what they do is they secure 10 petabytes a day, 10 petabytes a day that they bring in. They use SIM events. I mentioned that cybersecurity stuff. You might see SIM used because it's important to control those transactions. They have to make sure they're not being hacked. You heard Doug in the video mention NICU, neonatal ICU, saving lives. Cerner is one of our large customers. Anybody in healthcare probably knows Cerner. They're a business of healthcare data. They manage healthcare data for their customers. Maybe it's your payer provider, your insurance company that you use for health insurance. They're probably a Cerner customer. So they manage 2 petabytes in a secure multi-tenant environment. Multi-tenant because it's their customers, your vendors, your merchants that you use. They're securing the data with hundreds of clients. And it's millions and millions of patients. So they reduced hospital readmissions and saved hundreds of lives through what they do. Well, they're using data analytics on Cloudera to analyze patient data. And they're going back to their customers and saying, hey, did you know you can save more lives if you do this? Because we've analyzed people that did it this way. So they're changing how we do clinical medicine with what they have learned from data in Hadoop. Game changer, right? Cancer study, cancer research. I work with a number of hospitals that are doing genomic research, genetic research. I believe we're going to cure cancer, and Hadoop, I believe, is going to be a big part of that within the next 30 years because it's all about analyzing the data. What do we have? What are our traits? What are our conditions? What are we doing for our treatments? And you have to crunch that data on a scale. Generally speaking, if you're familiar with the Human Genome Project, a human genome is anywhere between 3 and 5 gigabytes. An individual's 3 and 5 gigabytes, each one of us. 10 years ago, individual research hospitals were using 10, maybe 20 genomes. They're so big, it had to operate at scale. Now we're in the hundreds or thousands of genomes. Some of them are public. Some of us might have our own genomes mapped. If, heaven forbid, we have some sort of rare disease, you're going to have your genome mapped. And that's going to go into a pool that might go to somebody like Cerner to control that data. Cool stuff. The US government. We use Hadoop to find terrorists with the US government. Suspicious activity on websites, maybe the thing that happened with Russia, who knows? But this is what we're using. We're crunching data and we're finding terrorists. We're finding linkages using Hadoop. Real-time data ingestion, warnings. Is that important for the Department of Defense? You're darn right it is. And we work with many organizations in the government, which we can't name here. So when we look at how we're going to use Hadoop, how we're going to use data, there's 3 dimensions that we look at. Driving customer insights, bringing customer data together. That's usually how we see it a lot initially. A lot of our customers are doing it for manufacturing. They're building a product, they're selling a service. They want to improve how they do that. It might be medicine, it might be building a solution, it might be a manufacturing line. And then the last one is lowering business risks. Maybe they're using it for fraud or cybersecurity. This is generally the way we see it. You think about where you are, think about how your data problems might map to that. I hate this statistic. 60% of big data projects will fail to go beyond the pilot phase. Why? Lack of planning, lots of different reasons. They don't plan right. They don't get the groundwork laid. They don't have the right data sets. They don't have the team that's trained. And this comes from Gartner in 2015. So the key here is, how do we do this the right way? Well, we want to map the right team. We want to build the right team. That doesn't mean Cloudera. That means finding trained people, people that know how to do Hadoop, and investing your organization's time into building the right mix. You can go out and buy Hadoop tomorrow. We'll sell it to you. There's a guy in the back that'll sell you tomorrow. You can buy a whole cluster of Hadoop. That doesn't solve your problem. You need processes. You need people in place to do it. You have to build the components to make it successful. So if you're thinking about Hadoop in your organization, it might work. Remember the people in the process part. You have to have it all. All right, I'm going to show you one more brief video, and then I'm going to get into analytics a little bit more. Everybody still with me? Everybody awake? Yeah? Okay. All right, here's a brief video.
It's truly an amazing time in technology. Data is being collected at a rate that nearly equals Moore's Law and transforming how businesses manage and analyze their information.
The conversation around Hadoop and big data has changed dramatically for the better.
Over the past few years, Intel's been demonstrating the value of big data by looking at malware detection, product validation, market intelligence, and recommendation systems.
Whether you're leveraging big data for customer 360 use cases, where you're anticipating your customers' needs, or if it's introducing new data-driven products and services, leveraging the Internet of Things. Or lastly, if you're addressing security, risk, and compliance, all three types of these use cases are boardroom level use cases, and they're transforming industry.
As processing power continues to grow exponentially, the possibilities of technology are limitless.
We're so pleased to be delivering these high-value use cases in conjunction with our partner Intel.
Together, Intel and Cloudera are making technology possible for businesses to accelerate their growth and improve operational performance.
So that was Kim Stevenson, the CIO of Intel, former, actually she just left recently, unfortunately. But Intel used to have their own distribution of Hadoop. They were actually in the Hadoop business and a competitor that we did. They started to work with Cloudera and they said, you know what, this isn't a business we want to be in anymore. So they threw in Cloudera, bought a piece of the company, and then they use it extensively internally. So I'm going to move on to SQL and then I'm going to do a demo for you guys. Everybody still with me? Yep. Okay. All right. So I mentioned 3 SQL engines. Why 3 SQL engines? We have Hive on MapReduce or Hive on Spark. This is for your batch workloads. So again, I mentioned the people in business intelligence or SQL, they want to write SQL, and they need the right tool for the job. So if you're doing big batch, if you're doing ETL, you're going to be using Hive. It's got functions and features that are optimized to do ETL. Impala is when we move into memory, in-memory delivery of analytics. Dashboarding. Anytime it's got to be fast and it's SQL, you're going to use Impala, which is BI, analytics, data science. They're going to do it that way. And finally, Spark SQL. Well, what's Spark SQL? Spark SQL is SQL in the Spark language. If you're going to write development, if you're going to write code, and you want to write SQL statements in your code for whatever reason, maybe you want to do it, maybe you want to optimize joins within your code, you can use Spark SQL. There's pluses and minuses for every one of these, but the point is find your fit for purpose. Find the right tool for your need. And you may be using all 3 of them, many of our customers do. So Apache Impala is an open source solution. Cloudera created it. There are over 1 million, I think this is 2 million now, since GA. Most of our customers use Impala. I would say half of all of my customers use Impala. They're doing structured data, they're doing SQL, they're doing analytics on some sort of relational database. Impala and Hive are often their first tools that we set up. Certification, here's some tools you might be familiar with. If you're using any kind of visualization reporting tools, you probably own one or multiple tools like this in your organization. They all work with Impala. Impala is the de facto standard. Multiple vendors support Impala. Here's a few of them there. So why do we use Impala versus an enterprise data warehouse? Impala is best for analytics, a dashboard. Whenever you hear dashboard, fast reporting, data discovery, self-service BI, they want to use Impala. Why? Because Impala is fast and it runs in memory. So odds are likely, if you have handfuls of gigabytes or even up to a terabyte of data set that you're going to report on a lot, Impala is going to be able to cache it in memory. So it's going to be even faster because all of that data is probably going to be cached. Faster performance over large amounts of data. So huge data sets. More flexibility, lower license costs. This is a big one. When we talk about the cost of Hadoop, the architecture gives Hadoop a big savings, but the open source factor gives it even more. So we save a lot of money with Hadoop because we're not buying expensive SAN, we're not buying really big servers, we're not paying a software vendor for proprietary software license. And then integration across the platform. So when we look at data warehousing, and a lot of us still use data warehouse, they're still great fit. Cloudera, Hadoop, they're not replacing a data warehouse, but there are workloads that can fit in multiple worlds. And the key is to look at which one fits best. Here's what fits best in a data warehouse. Regular complex reporting on highly modeled data. First normal form, second normal form. When you're doing a lot of model data, often millions of tables, millions of joins, transactional databases. That's good for a data warehouse. If you're doing larger scales, handfuls of tables, huge tables, you want to be with Impala. Highly modeled data, third normal form, better for a data warehouse. Fixed SLAs. Data warehouses need very, very short jobs. Slow changing dimensions, things like that.
I would say one thing, Derek.
Yeah.
That's kind of the present, but as things
Kudu.
evolve, things will change.
Yeah, and Kudu has started, thank you, that's a good point. Kudu has started to invade this world a little bit more because you do more of those updates. So common use cases again, Premier is a healthcare company, another one. We do a lot with healthcare and financial services, so why does that come up a lot? Those are two industries that Cloudera works with a lot because they care about security more than many others. So government, healthcare, financial services, they gotta lock it down. So visualizations, hospital spending across the board, thousands of client hospital purchasing systems, simplify the data. So dashboarding, anytime you hear dashboards. Data discovery, we have a major financial institution. Part of the times you'll see this is that a lot of our customers use our technology as a competitive advantage, and they don't want to be needed. So this is the way we can do it. Identifying fraud. So they'll be looking at fraud, and they'll find, like I mentioned, credit card transactions, not saying it's MasterCard, but there are banks that use our technology to find fraud. They're analyzing the internal systems, web logs for cybersecurity. A lot of things we see in those use cases. And they want to use their existing BI tools. All right, so here are some quick metrics. If you've heard of any other SQL solutions, here are some competing solutions that use SQL. You're not going to see a proprietary solution here because it's copyrighted, so these are allowed to be published. But I will say I believe Impala is the fastest on-Hadoop solution that exists in the marketplace. Here are some numbers. Single user workloads, shortest is better. Here's Spark SQL, still fast. Hive on Test is another competing solution we hear about. You can take the metrics with a grain of salt. Whenever I see performance metrics, I always think, well, who cooked the books on that, right? Anybody in the room thinking that? I believe Impala is the fastest, and we try to be as objective as we can and optimize every solution. But here are some TPC benchmarks for Hadoop. If you're familiar with TPC benchmarking, TPC-H is the standard that was created to test it. It's not a Cloudera thing, it's an industry. All right, everybody ready for a demo? You still with me? All right. So I'm going to do a demo for you that uses Impala and Hadoop and Hive. And I'm going to start first with the dashboard. You can see this. Okay, can everybody see this okay, or do I need to make it a little bigger? Is it good at this dimension? Is that okay? All right. So this is a cluster I created. I'm just going to show you a little bit about the cluster, and then I'm going to talk about the use case. So what you see here is Cloudera Manager. I mentioned that was the Cloudera management solution that we distribute with our distribution. On the left, you can see some dashboards. These are green. I can't really even tell they're green, like yellow green, but they're green. Green is good. Green means everything is working. So what you see here is a cluster. You see the version of the software. You see hosts, and I'm going to drill into that in a second. And these are all of the services or the open source projects that are running. Now, if I wanted to, I could run 100 different issues or instances of Impala. In this case, I'm running one instance of Impala. It could be across an entire cluster. So think about this because we're looking at a cluster. Now, I'm just running a demo cluster. This is only one node. But most of my customers will run anywhere from 10 to 300 nodes of Hadoop. Usually they'll start out at something small, maybe 10 in dev, 10 in prod, but that's usually where they get started. So these are some of the projects that you heard me mention before. If I look at the hosts, I can see certain dashboards, I can see metrics. Here's my server, happens to be hosted in Amazon right now. There are 26 specific roles. If you remember that chart I put up before about all those components, these are all of the components that are running on that one node. Now you would never do this in a real environment, it's just a demo environment, but that's what you can see. If you want to see more details on a specific host, you can look at a host. And if you have any monitoring solutions today that you use, you'll see stuff like CPU usage in host, and you can see it's flat because I'm not running anything right now. Memory usage, health tests. So these are things that we run on every component. You can see physical memory. Now in this case, it's physical memory for one host, but we could also see this if we were running a whole cluster. This might be terabytes or even petabytes of memory of RAM. So if we look at configuration, so let's step back here. I'm going to step back to my main dashboard here. I see the status is all green. I have my Cloudera management service. And then over here, if you can see these yellow things here, it's giving me a warning that I have configuration problems in my cluster. So if I click on that, if you can see the number, little wrench and a screwdriver with number 11, I'm going to click on the configuration issues. So these are things that are wrong with my cluster. This is what's broken. So the tool has detected what is broken right now with my cluster. Now generally what you're going to see here is things that are saying it's size too small, not enough memory because I'm running on one node and like that. But you'll see things like max message size for Hive Metastore, number of cores of Spark is too low, Zookeeper needs to be on 3 servers, things like that. It's basically telling me I got too small a cluster. Once you have a regular size cluster, you'll see this. But you can see things down here, recommended heap size for Cloudera management service. So the key here is to make it easier for somebody to manage a cluster, because it's going to look at those 2,000 parameters and it's going to tell you if something is out of whack. And it's constantly looking at the data because it's actually writing to a little relational database in the background. Usually we use Postgres or MySQL or even Oracle, but this is going into a transactional database because this is a transaction. It's a data transaction. All right, so that's Cloudera Manager. Let me get into the demo now. Okay, so what we're going to talk about, we call the golden ticket demo. So this is using Impala, Hive, you just saw Cloudera Manager. I'm going to touch my Q. And we're going to pretend for a minute that we're a cell phone provider. We're a telecommunications company, and we provide cell service for our customers, like AT&T or T-Mobile or something like that. And I'm going to run through what this use case is. So when you look at this, think about your organization. Think about the data problems you have today. What are your business objectives that you want to do with data? This is an isolated case for a marketing team in a cell company. What are the important data assets of your organization? Most customers that I work with today are looking at their data as a capital asset, like a machine or a building. Look at that in your organization that way. What are the data sources that you use today as part of your job? So in this case, our marketing team has come to us in our telco company, and they say they want to give away free telco service for a year, free cell service for 1 year. And we are the analytics team. They have come to us to solve this problem, and they want to float the idea as marketing promotion. So they've been asked, we've been asked, our team has been asked to select the perfect recipient for this award. So they think if we try this promotion out, maybe we can use this in an ongoing case and keep some of our customers, because we don't want them to churn. If anybody is dealing with churn, losing customers, it's a major pain point. We don't want to lose customers. It's expensive to gain a customer. And how many of you, show of hands, have changed cell providers in the last couple of years? Okay, good, maybe a quarter of you. I just did. So whenever we get close to our contract, we start to think about that, right? Think about, oh, maybe I could shave another $10 a month off my bill, right? It never works out. It didn't for me. But we think it will because we're reading the marketing materials. So telco companies churn a lot. Every 2 or 3 years in the US, they lose a customer because the contract ends and everybody thinks they can do better elsewhere. So they want to cut down churn through this marketing promotion. So they have said the ideal customer that we're going to give this prize to, we're trying this out once. We want them to appreciate the prize. So they win the award, they're going to get the prize of free service. And we also want to minimize the loss of revenue. It's got to be a cheap promotion. We're going to give $1 million customer away. So what are we going to do here? Here is our technical plan. Again, we're part of the analytics team. We're going to use the Cloudera Enterprise Data Hub to find the customer. We're going to import data into Hadoop, specifically the Hadoop distributed file system. So we're bringing data in. We're going to use Hive to ingest the data. So Hive is the tool that's going to set it up because we're setting up the structured data we want to query it for analytics. So we can create tables for each file. And then we're going to use Impala because we want to query the data quickly. We're analytics. We want to do it fast and in memory. So we're going to use the tables that we created in Hive, and we're going to use Hue, the Hadoop user experience, as the interface to write our queries. Okay? So I did steps A and B for us because they take a little bit of time there. So we are going to do step 3, which is Impala. So the data is already in Hadoop. Well, what data sets do we get? So again, we've got to find and select the perfect recipient. The customer needs to appreciate the prize and minimize the loss of revenue. And the marketing team gave us 5 data sources to work with. Customer profile, that's like our customer database. Call detail records. Now, a lot of times you'll have an industry-specific data source. For sub-providers, it's call detail records. These are the calls we actually make. Every one of the calls we make, whether it's on a landline or a cell line, has a call detail record somewhere. And there's some way of showing how the call is terminated. We're going to use Twitter, tweets. We're going to use web server logs and NetFlow data. If you're familiar with networking gear, NetFlow data is data that goes through networking switches. How much data, how much traffic. So those are our 5 sources. So how do we do it? Where do we start? We're going to look at our customer data set. Our customer data set has some key features. Account information, name, address, phone number, contract start and end date. This is going to be a big one. When does our contract end? Because we might churn when our contract is coming close to the end. Key address, phone, Twitter handle if we have it, and then a unique identifier. If you're familiar with the IMSI number, you open up your cell phone battery pack, you would see probably a white sticker that has an IMSI number. It's like your IP address for your phone. It's your unique address for that device. So we're going to start with that. So how are we going to do it? Well, let's go over to Hue. This is the Hadoop user experience. This is an open source solution on how we can talk to Hadoop in many ways. What we're looking at right now is the file browser. So this, you can see this folder structure here. If you guys can see this in the back, here's a folder structure. It probably looks like your Windows desktop or your Mac desktop. We've got a structured file system here, but we're looking at a cluster. So this cluster could be 10,000 servers with a file structure and all the files broken up. So we have 5 folders here for our telco data, and we put 1 set of files in each. So we're starting with our customer data. So in here, I have a customer clean file. I'm going to show you what that file looks like. This is my customer data. Does anybody recognize the format of this data? It's yellow, if you know it. Comma separated, that's right. CSV. So this is a CSV file. Comma separated because there are commas that separate every value. So you've probably seen this data. Excel can read this data. So pretty common data format. So that's what we're going to use, but we had to create a table out of this, and that's what I did with Hive. So what we're going to do is I'm going to go into Impala query editor, and I have one for Hive as well. And you can see on the screen here, there's an open box. This is where I'm going to write my SQL. We can see history and what jobs were run. We can see our database, because this is a database within Hive. Now, one thing I will tell you about Hive and Impala is they share the same metadata repository. So if you create a table in Hive, it's also available in Impala. It's a wonderful thing about it. So we have the same structure. So we have a Telco 360 database, and that's where I loaded all the data. And these are the 5 tables that we're going to use for this exercise. So the first thing we're supposed to do is to look at the customer database. So here's my select statement. If you recognize this kind of format, if you're SQL people, select star. I'm selecting everything from my customers table in the Telco 360 database. Pretty straightforward, right? Not a big deal. And what I'm querying actually behind the scenes is 200,000 records. And you saw how fast it came back. Now it has only sampled 1,000 of them for me on the screen, but this is my customer data. So this is what I'm going to use for this. Now you can see I mentioned that IMSI number. That's our unique identifier of our phone, contract start and end date, subscriber age, things like that. We see names, a lot of details. Now if I were redacting data and I had good security on my cluster, I don't, then I would not be able to read some of these pieces of information. That's what we would want. I did not set up proper security, so it fired me. But this is what it looks like. That's what we want to do with a good security control. So I'm trying this data, and again, if you think about who's going to churn, people that are going to churn are going to be people close to the contract end date. So let's go back to our guidelines here. And the first step did not really tell us anything at all. We know what the customer data looks like. So we want to find the recipient. So marketing figures that people that are going to churn are close to the end of their contract. Now, this data set is 2 years old, so we're going to pretend that it's 2015, July 2015. So we're going to look for people that are close to the contract ending, because they're the ones that might leave us. They're the ones that are going to quit and go to a competitor, and that's expensive. So the contract is nearing the end date. So we're going to filter our data set on the contract end date. So let's go back. Let's go back to our query here. And I'm going to expand this query. Oops. Okay. All right, so I'm going to go to my second query, and I've pre-built these queries for time. So I'm just going to select certain fields, and I'm going to choose still the customer's database, but I'm going to choose the contract end date between these 2 dates. So I'm going to run my query, So now I have a result set at the bottom. So here, first name, last name, unique identifier, here's the contract end date. So what I did is I looked for people between September and January that are close to the end date, because these are the people that are most likely insured. And I still have more than 1,000 results on my screen, so I know there's still a lot of people. So did we find our one winner? Not even close. So let's go back to the guidelines. We now know the people that have a contract end date from a customer database, but we need more information. How do we find the unhappy customers? Well, marketing says we're not really sure how we find unhappy customers, but we're pretty sure those are customers with drop calls. I know when I've got a drop call, I'm pretty ticked off when I'm in the middle of a conversation. So marketing figures people with drop calls are probably more unhappy. So we're going to use the two data sets. We're going to join on that unique identifier, that IMSI number. We're going to query and keep extending our query. So I'm going to go here, and you can see I'm now building a bigger query. And what I've done here is I've joined a second data set. I've joined my customers' data to my IMSI number. So sorry, this is self-join. So what I'm doing is I'm grouping by contract end date, and I've added in the CDR data. So here's my Telco 360 CDR. And here you can now see the number of drop calls. And all I did was I counted the drop calls and I sorted by the drop calls. So this is still my first data set, but it's now joined with the second data set that called drop calls. So we see here up at the top, Isabella Campbell has had 15 drop calls in this certain reporting period. She's probably not happy about that. So we're going to assume this is our unhappy list. Now it might not be perfect, but it's enough to go on for the promotion. But that's not enough because we've got to get to 1. So let's add in our Twitter data. So marketing figures, customers with drop calls are probably the most unhappy, and they may be tweeting information about drop calls. So if they're so unhappy they're tweeting, they're probably pretty ticked off. So we're going to add our Twitter data. Well, how do we add our Twitter data? Well, we may have gotten our Twitter handles in a couple of different ways. We may have asked our customers to volunteer their Twitter handle. We may have harvested it through the network because all of their traffic and their tweets might be going over the cell network. Or we may have paid a third-party company to help enrich our data sets. So we're going to add the Twitter data. Now, the Twitter data is in JSON format. If you're familiar with JSON format, this is what it looks like. So this is raw Twitter data. So what we've done is we've done a process with Spark and Scala and brought this format into a more structured format. But effectively, this is a JSON format. And there's a lot of open source libraries out there that use JSON ingestion. JSON is JavaScript object notation. So this is the structure. It has a semi-structure to it, but there's a structured format. So we brought that into Twitter, but we need to make it queryable in SQL. So let me go to my third query here, my fourth. So now I've added SQL there. Now you can see my simple select statement is now growing. I have multiple joins. I have Twitter, I have customers, and call detail record data. I'm running my query again. You can see my query history here. And here's my result set. Now look what happened. My data set went down to 6 results. So I've joined and I keep expanding it. So I've got people near the contract end date, lots of dropped calls, but now I've filtered where somebody tweeted with the words dropped call. So let's see what they said here. We've got the actual text. Another dropped call off your terrible towers. That's not good. I feel like I get a drop call every time I open my phone with you guys. Get it together. Sucks to have a drop call during a job interview. You're killing me. Okay, so this person is probably very unhappy, right? And these may be things that you guys have tweeted in the room. I don't know. So Caitlin was certainly pretty ticked off if she didn't get that job. So, but we're still down to 6. We don't have the total answer yet. Let's add another data source. So what if we added our web logs? So what are web logs? Sometimes you'll hear clickstream data or web sessionization. We're going to use the web logs that we have harvested from our customers using their cell phones. So if you've ever used your cell phone to look at the internet, look at the web, you're going through your cell provider's network. Now, this is where people might start to say, well, that's a little creepy, right? You know where I'm going and you're looking at where I'm going. Guess what? They're doing it. And they just passed a privacy law where the vendors can now sell the data of where you're going. So get used to it, right? Now, is it creepy? Some might call it creepy, but you may have data sources in your organization that's specific to you. And our telco company has said, well, use it. Let's use it. So we're going to use the clickstream data of where they went, and we're going to look at the customers that went to competitor pricing pages. Because we know if they went to our competitor site, like AT&T and T-Mobile, they were looking at the page that said pricing. So if the website says pricing on a competitor site, they're more likely to leave. We know that. So let's go back to our query, which keeps growing and growing. So again, we've added the tweets now, and we have also added the clickstream data. So you'll see clickstream here. It's a table of clickstream data. So I'm going to query it now, and you can see my simple select has gotten a lot longer. But I'm still doing very basic analytics. So what happened now? Now we're down to 2 results. We have 2 people now that fit the bill. So the contract is near the end date. They have a lot of dropped calls. They tweeted negatively. And now we also know that they went to the competitor webpage. Well, how do we know? Well, there's our tweets. And there's the URL they went to. Pricing, cheap plan, or pricing. So we know they're looking at the competitor website, so they're probably thinking about leaving us. But we're only down to 2. Let's add one more data source that we got from marketing. Oops, I ruined it, didn't I? Okay, so let's add our net flow data. Oh boy, that blew up on me, didn't it? So we have clickstream data. We're going to now add net flow data. See, one of the things that the marketing people said is find somebody that does not use too much data, because we don't want to go broke. So we don't want to give it away to somebody that was using a lot of data usage. So we're joining our net flow data. And again, net flow data is showing the data usage on our network. Not just a cell network, but any network. So we're going to take our select query. We're going to join our last data set and run the query here and see who wins. Again, I'm running this on one node, so if you're wondering why that's slow, it's only one server doing this on the set. Okay, so we still have Ashlyn and Caitlin. They're seeing 2 people as last time, but now we also have their data transferred. So if we look at it, this number is about 20 times more than the other number. So Caitlin is using 20 times the amount of